Howdy everyone, thank you for joining us again. It's midnight where I'm at, can't sleep, so I thought I'd make a video because there's nothing like not being able to sleep and talking about the OSI model at the same time. Hopefully that'll help me sleep. Today we're going to talk about the session layer of the OSI model and the importance behind that, as well as what it does. And again, just like the other videos, this is broken down piecemeal, so you can take it in smaller chunks, bite-sized chunks to deal with instead of trying to understand all of it at one time. Of course, if you have any trouble with the OSI model in general, understanding the concepts, you might want to start with watching the high-level video first. With that, let's just go ahead and jump right into the OSI model or the session layer of the OSI model, and let's get it going. So, first thing, much like all the other layers, there's different labels for the type of data there, and in the session layer it's called a message. So, and much like the other layers, so the physical layer was ones and zeros and called bits, and they were chunked together at the data link layer called frames, and then those were chunked together and called packets at the network layer, and so on and so forth. So the same process keeps going on all the way to the top. And the OSI model allows applications to share a connection. And the whole purpose behind this is that if you had a single server that performed multiple duties, like maybe a file server, print server, email, whatever, then the singular connection to that server is what allows for the it allows for the different applications to run through that same connection. All right. The important thing to remember, especially for test taking purposes, is that the session layer does name lookup, security, and error checking. So again, in relation to error checking, don't forget that the data link error starts off with some form of error checking, cyclic redundancy checks, CRC checks, but then the network layer has it as well. Every layer pretty much has its own form of error checking that is relevant to that particular layer, with the exception of the physical layer that doesn't really do error checking. So one of the cool things about the session layer is that it's basically if there is a session with point A to point B, and then you get disconnected from the server or whatever that you're connected to for whatever reason, then essentially this allows for the session to be reestablished. So I'm sure at this point in time, everybody's had a situation where they've started downloading something and then you got a failed download, but you had the option to resume. Welcome to the session layer. That's what makes that possible. So kind of cool. Otherwise, you'd have to start the download all over again. And with today's ISOs and operating system files like Linux and things like that, several gigabytes, you don't want to start a several gigabyte download all over again. All right, data is transmitted by 3 different ways: simplex, half duplex, and full duplex. I'll just discuss those real briefly, but we'll go into full duplex and half duplex a little bit more, and you'll see some graphics on that. Simplex is view simplex transmission as if it's like in the Wild West, like in the 1800s when somebody sends a telegram. You're sending the whole telegram all at once, and the person gets all the data all at once. Instead of a conversation, which is more along the lines of half duplex. Half duplex, since we're going into that. So again, simplex is really like sending a telegram back in the 1800s or whatever, and the whole thing gets sent, and then the person reads it, and then they send a whole other conversation back. Half duplex is different. Half duplex is where you have, it's much like a conversation with 2 human beings, or maybe a CB radio or a radio in general, walkie-talkie or something. When one person talks, they press the transmit button, then they talk and the other person listens, and then when they're done talking, then the other person presses their transmit button and talks back to the initiator of the conversation. So this process goes back and forth, and realistically it's like a normal human conversation with one person talking, the other person listening, and then the roles reverse, and it goes back the other way. Full duplex is different. Full duplex is awesome. Full duplex, imagine this, it's like two people having two separate simultaneous conversations, obviously at the same time, and both parties understanding completely what the conversation is about for both of those conversations. That's full duplex. Much more efficient, much faster for sure. All right, much like the data link layer, there's three sub-layers of the session layer: the connection establishment, data transfer, and connection release. Highly descriptive titles of what the sub-layers do in relation to the session layer: establishing connections, transferring data, and then dropping the connection or releasing it. All right, so let's get into simplex, half, and full duplex. Again, simplex is when one station transmits everything, much like listening to a radio or a television station or a telegram from the 1800s. Everything is sent all at once, and you either got it or you didn't get it. If you're not there to get the telegram, then you don't get it. If you're not listening to the radio at the time whoever is broadcasting, then you will miss whatever they were broadcasting. Same thing with live TV shows. You're either watching it at the time it's live or you're not. All right, half duplex is much like I said before. It's basically just a conversation between two people. One person talks, the other person listens, and then at some point in time, the person talking takes a pause, and then the person who's listening then responds, and then this just goes back and forth. It's very social in relation to human interaction and conversation, and half duplex. However, here's the good one. Full duplex. This is obviously the desired transmission because it's faster, much more efficient, but it does require some equipment. So you have to have a switch, and then you have to have a full duplex network card, and collision detection has to be turned off. Now, the reason you have to have a switch and the reason collision detection are turned off is because of they're both interrelated. The reason you have to have a full duplex network card is because in order to do true full duplex communication, more pairs of wires are in use on the Ethernet cable. So let's talk about that for a minute. All right, so the reason a switch is in use or needed is because it limits the collision domain to just two devices. And this is really the difference between a switch and a hub at the most basic level. In a hub, you have what's known as CSMA-CD, Carrier Sense Multiple Access Collision Detection. And what that means is, in order for a device to send data, it has to listen to the line, to the Ethernet or the network, and find out, is somebody talking at the very moment I want to talk? If they are, then I wait a little bit, and there's a mathematical equation on how long to wait. But it has to do with the time of the machine. But anyways, and then if there is nobody talking at the whenever, then the computer sends a packet to the hub, and at the hub, or frame at the hub, sends the data to the hub, and then the hub retransmits that data out every single port except for the one it came in on. A switch is different. A switch, once devices connect to a switch, it builds an ARP table and a MAC address table inside the switch itself. And then when a computer wants to talk to another computer, computer A sends a packet in, and it goes, oh, computer A wants to talk to computer B. Well, computer B is on port 8, so instead of sending it out all other ports except for the one it came in on, the data only goes out to the port that the computer is on. So because of this feature, because switches have this capability, there's no reason to have collision detection because it's talking just from one computer to the other computer, and switches on the inside, the guts of the switch fabric and the back plane and all that good stuff is smart enough to prevent really the need for collision detection. All right, so because of a switch and the type of network card and the proper wire in use, using all of the wires inside of Cat 5 or Cat 6 or whatever, then that means that the two computers can send and receive at the same time because they are using different sets of wires for what they're going to do. All right, the problem, however, with full duplex is that the slowest operating system is going to determine the fastest speed. So if you had, say, a laptop, let's just say two exact same laptops or computers in general, but one was 100 base T or 100 meg, and another one was a gigabit connection. The reality of it is, if those two talk to each other, they're only going to go as fast as the slowest link. So that would be, a 100 meg Ethernet connection. So that's the issue with full duplex. Now, is that really an issue? Probably not, because I don't think I know of anybody who has less than a gigabit connection on anything nowadays. Well, there's a few IoT devices, now that I think about it, that probably don't have a gigabit connection. And in relation to the concept between half or full duplex, I do have a weather device that tells me the temperature and how much it rained and things like that. That is a half duplex connection for that. And you can tell it, based on what kind of switch or hardware or something you have, in your house, your office, wherever, what the duplex connection is, just by looking at the lights, assuming the switch has the capability of LED lights that tell you if it's full or half duplex. And from the troubleshooting standpoint, knowing or understanding that something could be full duplex, you can hard code a switch to where the port is at half duplex. So if somebody's complaining about being slow, then maybe it's simply a setting in the switch where you're not transmitting and communicating at the same, or transmitting and receiving at the same time. You're not full duplex. Maybe you're set at half duplex, which is literally half the speed of whatever it could be. Another way of looking at it in relation to half duplex, if you're a network engineer and you have somebody who likes to dominate the bandwidth and take up all the internet, dropping them back to a half duplex connection may free up some bandwidth for other people in the company. So all sorts of options. So here's an image of how half duplex really works. So essentially we have a computer over here on the left. It wants to transmit data to the computer on the right over here. It goes to the transmit area of the network card. First thing the network card is going to do is there a collision on the network, or are there people talking on the network? Because I don't want to create a collision, so I'm going to detect traffic. If there's nothing there, then it goes, am I talking to the loopback? Okay, I'm not talking to the loopback, so then I'm going to transmit the data to the receive chip or the receive side of the network card on the other computer. And then the same process is in reverse. To expand on that, let's say this computer wants to talk to that computer, goes to the transmit side, it listens, oh, there is a detection of a collision or people on the network, so I don't want to create a collision, so I will wait a random amount of time. And again, there's a mathematical equation on the randomness. And then it will transmit. But it could also say, hey, am I transmitting? Am I going to 127.0.0.1 like when I browse the internet? If I am, then I would just simply go to my own receive side of the network card and then process the data myself. So you can see, just looking at the graphic itself, that there's a lot of busy work in there. Nothing wrong with that. It's just that it's real busy. Well, if we look at it, and I do say half duplex is like a one-way bridge with only one car allowed at a time. If you've ever run across those cases where you're driving and you have to wait for everybody on the other side of the bridge to cross, the bridge itself, and then you guys can go, and it's similar to half duplex. However, here's full duplex, or a bridge that everybody can go on at the same time, back and forth, both directions. So super simple. And the secret to this really is the fact that we're using all of the wires and the cable for a full duplex connection. So we have a computer on the left, wants to talk to computer on the right, it just goes, okay, I want to talk to you, transmit. There's a switch in here that makes this happen in the middle, but it goes to the receive side of the computer on the right, and then at the same time, the computer on the right can transmit to the computer on the left using the same process. So it's really, really kind of simplistic and definitely effective. And with that, I thank everybody for their time and so on. Oops, and I forgot this. All right, so we need going back. We need a full duplex network card, collision detection disabled, and a switch. And I did forget that there are session layer protocols to remember. However, let me just go through this. I'm going to just click through this real fast. These are the session layer protocols that you might be interested in. The reality that you're probably going to have to care about this in real life as opposed to a test is probably pretty slim. But if you need it, there they are. All right, now with that, thank you very much for your time. And if you have any suggestions, any comments, or anything else that you'd like us to work on or so on, then feel free to let us know. And with that, I will see you guys later. See ya.